This lecture is part of an online course on multivariable calculus, and I'm going to talk about implicit partial differentiation. So let me start. We have two types of formulas. One is explicit formula, where in the explicit formula you have, for example, z as a function of x and y. Okay, z is one side, the function is another side. As an example, z equals to square root of 4 minus x squared minus y squared. Okay, then we have another types of formula which is called implicit formula. On the implicit formula, we just have f of x, y, and z all together. So in the implicit formula, we don't have a clear z equals to a function of x and y. As an example, x squared plus y squared plus z squared equals to 4. So what is that? It's an equation of sphere of radius 2 at the center origin. And as you know, sphere has two halves, and each of the halves is going to be described as an explicit formula like this. So this is the top half of the sphere, and I can write this as z equals to negative square root of 4 minus x squared minus y squared. This is the bottom half of the sphere. So the question is how to calculate partial derivative of z with respect to x and partial derivative of z with respect to y when we have an implicit formula x, y, z. And the implicit formula, how can we differentiate z with respect to x and y? Let me give you one example, and then we're going to see on the example. Assume that we have equation of the sphere plus z squared equals to 4 of radius 2, the center at the origin, and the question is what is partial derivative of z with respect to x? Okay, I'm gonna say what? I'm gonna start with taking derivative of both sides of this equation with respect to x. Okay, so I'm gonna write derivative with respect to x of x squared plus y squared plus z squared, and it's equal to the partial derivative with respect to x of 4. So basically I take partial x from both sides. Okay, of f of x, y, z equals to 0. Okay, so now you may notice that z is a function of x and y. So I have, if I want to graph a tree like this, z is a function of x and y, but x and y both are independent variables, okay, because I have z of x and y. And now let's start and take derivative. So I have what? Derivative of x squared with respect to x would be 2x. Derivative of y squared with respect to x, I can write this like that: 2y derivative of y with respect to x. I could also write this part as 2x derivative of x with respect to x. And I'm gonna write z squared as 2z partial derivative of z with respect to x. And it's equal to derivative of 4 with respect to x, 0. Okay, and now this is equal to 1. Partial derivative of y with respect to x is equal to 0 because y and x are independent variable. Y is not dependent on x. That's why this derivative is 0. And I'm looking for this one. So the next step is to solve. That was the first step. The next step is solve for derivative of partial derivative of if z with respect to x. So I'm gonna bring this one on the other side. This term is 0, and then I'm gonna divide this by that. So derivative of z with respect to x would be negative 2x divided by 2z, which is negative x over z. Perfect. Now what is partial derivative with respect to y? The same idea. Let me make this into a box. Okay, now I'm gonna take derivative on both sides. Y squared plus z squared equals to partial with respect to y of 4. And so I get what? I get 2x derivative of x with respect to y, 2y derivative of y with respect to y, plus 2z derivative of z with respect to y. Derivative of 4 with respect to y is 0. So since x and y are independent, this is equal to 0. This is equal to 1. I'm going to bring 2y on the other side, and I'm going to solve for this. So then derivative of z with respect to y, it would be negative 2y divided by 2z, which is basically negative y over z. Okay? So whenever that you have any implicit equation, I suggest that you graph this tree that says that z or x are function of x and y. Then take derivative with respect to the variable that you want from both sides of the equation, and then solve for the partial derivative that you're looking for. Let's look at one example. Actually, I'm gonna write the explicit example first. If we have the explicit formula, and then we have z as square root of 4 minus x squared minus y squared. Now, what is the derivative of z with respect to x? Okay, so I can rewrite that as 4 minus x squared minus y squared to the power of 1/2. So derivative of z with respect to x, it would be 1/2 the inside function to the power of negative 1/2, and then times derivative of inside with respect to x, which would be just negative 2x. Okay, so this one is going to be cancelled with that. And then let me write this as negative x over 4 minus x squared minus y squared, and square root of 4 minus x squared minus y squared is given as z, so I get negative x over z as the partial derivative of z with respect to x, which is the same thing that we got for the explicit equation. Okay, let's look at one more example. Suppose z is defined implicitly by x squared z plus sine y equals to 5z squared. Calculate partial derivative of z with respect to x. Okay, so I'm gonna take derivative with respect to x of both sides of the implicit function that I have, plus sine y equals to derivative with respect to x of 5z squared. And I know that z of x and y is my function, so I'm gonna graph the tree. Now I want to take derivative. I know that I have product rule in here, so it would be derivative of the first one with respect to x, so it would be 2x derivative of x with respect to x times z, plus derivative of the second one which is that, times the first one. Then derivative of that, it would be cosine of y, derivative of y with respect to z. I'm basically writing the chain rule, right? Sorry, with respect to x. And then derivative of that with respect to x. 5 is a constant, I'm gonna write that. And then I have 2z derivative of z with respect to x. Okay, now this is equal to 1. I'm looking for this. Derivative of y with respect to x is just 0. So the whole term here is 0. And I got this. I'm gonna bring this one on the other side, so I get 2xz. It's equal to 10z minus x squared, derivative of z with respect to x. Now I'm gonna isolate partial derivative with respect to x, which is 2xz over 10z minus x squared. Very good.